adjust the level of the video. So and today should be better because they're not over there and whatever, but it messes with our classmates who are sick and at home and trying to watch the video actually. Like Olivia maybe tried to watch the video, or Mirabelle maybe tried to watch it. Like, it makes it harder for them to hear it. So if we can try to keep, like, consistent sound and not go, like, super high highs and super low lows. Actually, the super low lows, that's okay, because that's when you guys are working. But if we could just avoid me having to try to, like, overpower you, that would help with the quality of what our classmates who are sick are trying to watch and catch up on. So, expression mat is this. If you were gone, if you don't have it, make sure you have that out. You're going to want a bag of algebra tiles. Algebra, but it's spelled like algebra. And go ahead and get out just x's, x squareds, and 1s. So nothing with green, right? So x's, x squareds, and 1s. Get out some of those on your table and like kind of make a little pile somewhere. Or you could pour out some and then put away. You can pour them out and then put away what you don't need. That's okay. Now, hold up. You don't need to talk to do this. As we're diving into this, I want to reinforce one thing we said about x. X doesn't have a fixed length. X is not countable. We don't know what it is. As Logan nicknamed this that he made for me, it's a flexible x. Likewise, we don't know what x squared is, because it could, like, x could be a lot bigger and it would be a bigger square, or it could be a lot smaller and it would be a smaller square. So you want a pile of those somewhere on your desk. Why did I write on mine? Because I show them to the class in front of these little video things. Like, I should flip over to this side and label it what? Negative x squared, right? This is the opposite of x squared. It is the missing x squared. On our paper, we would show that as just a blank box, as opposed to a shaded box, right? Now, on the top of your homework paper, practice paper, whatever you want to call it, right here, notice you have this space open. You might want to grab some highlighters. We want to make sure before we dive into this lesson that we understand all the vocab that we're working with. So we're going to write out an expression and label or color code or point arrows to those different pieces parts. So if you want to grab highlighters, do so really fast. That is yesterday's. Yeah. Hey guys, make sure you didn't grab 612 again. Make sure you got 613. Sorry, I did not put these away yet. And actually, these are in the wrong spot because it was actually Tuesday. Those should be in the Monday. Oh, and if my bin is ever not here, Rico, if my bin is ever not here, it's probably over there because I've been grading papers and like I've actually been taking it home as I have a ton of paper. I'm hoping at the end of class to have some time. I got a bunch of papers to pass back to you guys. And on that point, guys, this is out of control. This is more no-name papers than I think I've ever had at one time in my entire 8 years of teaching. Please write your name on stuff. We're all guilty of it at one point or another just because we forget. But, like, have pride in your work. Put your name on it. Claim that, yes, that is mine. I did that. All right. So if I wrote out an expression, and you don't have to write the same expression as me, but if I wrote out like 5x squared plus 3x minus 7, right? Something like that. You could write out the same expression if you want. What is, and you know I'm going to use random cards. What is a variable, and where do we see that or them up here, Callie? Actually, we're going to shuffle. It's been a couple days since I shuffled, and we've been going through the deck fast. Oh, yeah. Yeah. Totally skip. Molly, what's a variable? You don't even have to tell me up here, just what's a variable?
Variable what it is. It's just hard to explain.
I know, that's why we're doing this. You're right. You know what it is, but it's hard to explain. You want to pass for the time?
Yeah.
Toby, what's a variable?
Oh dear God.
God is actually kind of a variable.
There you go.
Why could we say that?
A variable.
I'm not trying to make light of religion. I'm serious. Like, you could say God is a variable.
Is a variable just like a piece of something?
Close. A variable is Bella. Ooh, not necessarily something that changes. It can be, but something we don't know. And this is why when I was growing up in the Methodist church, I was always, or regardless of what church, I was always kind of blown away that we had pictures of God or pictures of Jesus. Like, we don't know what they looked like. Even Jesus, like, you can argue, okay, we might know what Jesus looked like because he lived back then and people could, like, draw pictures and things like that. And if you're not religious, that's totally fine. It's a historical text as well. He was a dude. He did some things. He might have been a magician. Maybe he was, who knows? But, no disrespect meant to anyone. But, like, we don't know. We don't know what he looks like. I always thought that was kind of like, come on. Jesus has long hair and is a white dude. Especially back then, there weren't really white dudes back then. Everyone was living in the desert, so everyone was probably tan. It's the x squared or the x, right? It's the letters. So if you're highlighting, and I wrote this in blue, a variable is something we don't know. We represent it by letters, right? So for us, variables are going to show up as letters or symbols, but we really mainly use letters. Well, ironically, your card was next, so we're going to skip that. Nikki, if I ask you how many terms are in this expression I wrote, are you able to tell me? It's okay if you can't. That's why we're doing this. Skip. Eric?
Can you repeat the question?
How many terms are in the expression?
2.
You sure about that?
3.
You sure about that?
No.
One of the answers you gave was right.
Yeah, isn't there like only one because then it's
Only
just,
one? Well, don't go backwards now.
No,
Dave? Mirabelle?
Oh,
Sorry, that's an A.
Can I
Parts of an expression. What are you trying to say?
Me?
Yeah, sorry.
Well, the addition and subtraction are the ones that like split it up.
Yep.
So they're like, if you look at it. 1, 2, 3.
Yeah, so this is a term, this is a term, and this is a term.
Split it.
Please do this with me. I'm getting concerned by calling on people and not being able to answer. I should have waited to give you the tiles, because now I see some people just playing with tiles. But you need to know these. They will be on your next mastery. By the way, tomorrow we are going to go over your Chapter 5 masteries. Pretty much all of us would have gotten a progressing, which isn't a bad thing, but we've got mistakes. Even if you did well, you've got some mistakes. So we want to go back and fix those things. We're going to go over that together. We'll have a progressing to mastery, not really homework, but like do it whenever you get it done. And there won't be any new lesson homework. And I'm not going to ask you to turn in homework tomorrow, but if you have 611, 12, and 13 done, you can turn those in. Like, that'll be up to you. But I'm not going to say you have to or that they're due. I do need to update math. So one last call. If you are behind on turning in homework, please do it now. Molly, don't mix your highlighters. Then they all look the same. I know, it's fun. You can actually do it on your paper, like just picking up some of the... Okay. We with me? Why there's 3 terms. They're split by the plus or minus. And guys, I would write that down. If you did not write split by the plus or minus, I would so write that down. Are you leaving us or just throwing something away? Make sure if you're leaving us, you know what coefficient and constant is. Otherwise, you should hang out till we finish that. Okay. Nick, do you know what a coefficient is?
No.
Totally fine. That's why we're doing this. Sarah? Zach?
Isn't it like a number
Switch what you just said. Not dividing.
You're not dividing.
Well, what is not dividing?
Multiplying.
Multiplying. The coefficient is the number. I'm going to use hashtag symbol because I'm running low on space. Number multiplied by the variable. So guys, our coefficients here are the 5 in front of the x squared and the 3 in front of the x. It doesn't matter if your variable is x squared or x. That's a coefficient. Now 7 is not a coefficient because, Araya, what is the 7 or the negative 7?
Negative 7 is subtraction.
Yeah, and why is it not a coefficient?
It's not a coefficient because it doesn't deal with multiplication.
And a constant is a number. Oh, that's still highlighted. Sorry. Anyone know how we define constant?
Is it the division? Whole number?
It's a number we know. That's it. The constant. Yeah. The number we know is the minus 7 or the negative 7. You doing this with me? Because you look like you're making art, which I know you make really good art. I want to make sure we know this. So this messes with kids. Because a constant does not change. Right? So 3x will change depending on what x is. 5x squared will change depending on what x squared is. But this negative 7, guys, that's like these tiles. You know what these tiles are. This is 5, right? Or negative 5. Or like 1 or negative 1. Right? Like these are constant. Their size can't change. They don't involve x. They're not elastic. They can't change. They are constant.
Look how cool it looks because it's like orange and then it starts on one and then it fades.
Right, it turns into like
pink,
red.
and it's like
So also, in your book or your ebook, if you need a reminder and a really full-on definition, they have all of that defined right at the end of this lesson. So you might put a little star on your paper and say like 6.1.3 math notes, because that's what this is. It's a math notes box. If you need to go back and review your vocabulary, please do that there. I did not have space on your homework to put that math notes box, so that's why we just did that. So hopefully you did that. If you have any confusion later, please come see me. We are moving on. So Maria, and this is on your paper, on your like worksheet that I handed you. Maria's been recording her work to see each side of the expression comparison, right? So we've got mat A compared to mat B. If you want, like I do, I would kind of draw a little dividing line between these. Mat A and mat B are normally split, right? So I would draw a little dashed line or something. Now, Garth, Mr. Brooks, right? Garth wants to know, like, what she's doing. Garth missed class. He had coronavirus. He's okay. So he goes back and he looks at Maria's work and he's like, okay. But Garth is honest and he says, I don't know what you did. I need you to take a moment on your paper, show what Maria did. How did she get from one step to the next? Circle things that went together or write things in between the steps. I'm going to give you about 60 seconds to do that and ask for your help to explain to Garth what did Maria do. What do you mean do it in real life? You can, but we don't need to. I would like you to like show on your paper what's happening before we do it. Also, why did you not write down the definitions for those words? Oh, on your graph paper you put. Did you see that I had space for those right here?
Oh, well, I was on the wrong side.
Oh, okay.
And I was very confused, but then I was like, oh, the holes are on the wrong side. And then I flipped
Wait,
it.
so the holes are on the right side. They're correct. They're good.
We call my grandpa Garth because
Oh,
his
nice.
last name is Arth, and his grandpa.
Grandpa Art. That's awesome.
Yeah.
I like that. What did I come over here for? Ah.
He's very easy. Then I call my grandma T. You call your grandma T?
Let's see if I borrow a pencil since I was nice and let Toby have mine.
Toby, why do you not have a pencil?
Very interesting.
I had one, and then I came back and it wasn't here. I looked all around the ground.
You know, if you hadn't spent your creative start time off task, you wouldn't have had to leave class and then come back. It's things we've been talking about all year, man. Time and place. Like, that would be funny if it was appropriate time and place, but it was wrong time and place. Not fun. All right, now Olivia, you've been gone, so no pressure at all. But I go by the cards.
Oh, I get
Skip
it.
if you want.
Sorry.
So, Olivia, how did she go on the left side from step 1 to step 2? Yeah, so really we call this combining like terms. So if you were like on a game show or something, and they're like, what are the 3 words that describe this being added with that and getting this? It's combining like terms, right? 2 and -6 are like terms because they're both constants. Right? They don't have variables. So then on mat B, same thing, right? I won't even call it anyone different. She combined the like terms. Any questions on how that happened? Nope. Then Callie. How do we go from step 2 to step 3? Oh, yeah. Lily? I don't even know. She does something to both. What's missing when I go from here to here? What has changed? Yeah. So guys, if we were like drawing this out on a mat, we would have circled the 2x and like drawn an arrow out. But algebraically, we do minus 2x. So if you want to write that out, that's probably a good idea. Yeah. Morgan, we hope you feel better. I think you are gone today. Meredith, what about going from step 3 to step 4?
Don't they just do this 3x and then they like take away the
4?
4?
Is it 4?
Negative.
-4. So if we take away -4, it's the same thing as just add 4. So what we could show on both sides is she actually adds 4 because that makes 0. And we get 3x equals -2. Or not equals, but 3x compared to -2. At this point, Garth is like, all right, Maria, so which side's bigger? And Lydia, what would Maria's answer be? To which side is bigger? By the way, if that thing's awkward, feel free to have Lee scooch over so you guys can scooch over. I know the desks get pushed sometimes. If you don't know, you can totally pass. What does Maria tell Garth, Callie? Yeah, because why? Yeah, this is just a variable term and just a constant term. We don't know how these compare. We don't know yet. But we got it down to a pretty simplified version. 3x over here, -2 over there. If somebody tells me what x is, then we can figure out which side's bigger. Any questions on what Maria and Garth did there? Nick?
Couldn't we assume that 3x is bigger because it's not negative?
No.
X could be negative though.
Well, wouldn't it write like negative?
I could plug in -2 where x is. So if somebody tells you, and I'm not going to use -2 because we have a -2 up here, but if somebody told you x was -4, that means the positive x is a -4 value. So this becomes 3 times -4, that would be negative 12, and then we could compare, but we don't know what x is. Now, if we're talking realistically, looking at like your tiles, we assume x is probably positive because it's like a length, right? But we know by algebra, it doesn't always work that way. On your expression, Matt, go ahead and build 2 plus 2x plus negative 3 on Mat A. And this is 1. It's not ion, whatever. So we're going to build 2. Yep, so I'll do it with you guys.
Oh, God. I was there.
2 plus 2x. The rectangles, remember, the rectangles. Because the other ones are x squared. Remember, red is negative when we're using tiles. 2x plus negative 4.
Why didn't they put a space between the 1 and the on?
I think that's a format issue because I zoomed in, and I think when it zoomed, it just didn't format correctly. Then, now those aren't x's, those are x squares. These are the x's. Guys, remember, these are x's, the rectangles, the blue squares are x squared because they're x by x. You are welcome. What, if we think back to the work we did on our resource paper, what could I do with Mat A, Molly? Give me one thing I could do with Mat A, my left side. I could take out both of the x's. So guys, I'm going to use my space down here to be tiles that have been removed. Now if I take out these two x's, what else do I have to do? I have to do the same thing on both sides. Sweet. So we can do that. Savannah, what else can I do? We'll put you back in the stack. Luz, what else can I do? Yeah, this is tricky because now we have to think in red and blue versus like open and like shaded. So if we take away these 3 negative, what else do we have to do, Luz? Yeah, we have to take away these 3. I couldn't quite hear you, but I want to make sure we said we have to take away 3 negative from both sides. Now there are other ways. Remember, we talked about this like for all week. We've talked about there are other ways. Sarah? These together make what? 0, so they can just come out without anything happening over here. And what do you end up with? 2 compared to 0. You got 0 and negative 2. Yep, same thing. A is still bigger. Right, so that, guys, this is the physical representation of what we've been doing by drawing circles and grouping and removing. Does that make sense to figure out that A is bigger? Doesn't matter what results you ended up with. We can slide all of these back up, actually, and say A is bigger. Now, the other way that some people probably did it was they made this into 0, and you made, this into 0, and then you removed that, and then you removed the negatives together, and you got 0 and negative 2. But still, A is bigger. So actually, here's what we need to do. So the symbol we would put for this one would be A is greater than B. Yeah, look at that. I'm making resources on the fly.
Are you using this for the next class? That's why you put on sticky notes.
I mean, probably. I have to use it for the afternoon class for sure, assuming I don't lose things. So, is this what we just had? No, it's different, right? Build this on your expression, Matt. We got 2 x's, 3 positives, and 1 negative. Hey, we're all building. We're like Bob. Take, I don't know, 30 seconds. Pull everything off that mat that you can. Reduce it as far as you can. But that's what we have, right? 2 x's, 3, a negative, an x. Go, now. Go. This is one of those days where we do more than we write.
Mr. Hudson, I'm finished.
Good. Would you like a blue ribbon?
I would.
What do you need it for? Tie up a box or something? I do have math counts ribbons somewhere, but they just say like mathly. No, I am only doing math counts right now with the team that's moving forward, just because like we have to work as a team. They're going to States on the 7th of March, which is pretty soon actually. After that, now if anyone wants to do the video challenge, that's a good opportunity that you can even do for Discovery Day, because it just has to be submitted, I think, by March 7th. Bella, give me one thing I could do. I mean, you can just look at mine if you want. I can take away 3 from each side, because there are 3 available on both sides to take away. Awesome. Nikki, what else? Take away 1x from both sides. Eric, and then?
Well, then that's pretty much it.
Crap. Can I compare x with a negative 1 to 2? Yeah, we don't know the value of x. So this situation is going to end up with in between them a question mark, right? We do not know. Is A bigger or B bigger? Well, somebody tell us what x is, and then we could figure it out. X is 90. Well, we don't know that. Well, x changes. So, did we, hey, because I teach this class twice, I do genuinely forget what I talked about with one group versus the other. Did we talk about graphing inequalities yesterday on a number line? Okay, that's what I thought. So, on your paper, actually, let's go back here. Back here. I don't like the question mark, right? That makes me upset. What if I wanted to go ahead and force A to be bigger than B? I think we talked a little bit about this. How could I get rid of this negative 1 tile? This is seeing who was paying attention yesterday. Eric? Because I can't take away the negative because I don't have a negative over here. Araya? Positive on both. Yeah, sorry, that was one way. My brain is, there are 2 ways. So sorry, say it again, but say it louder because I cut you off.
You bring in a positive on both sides.
If I do the same thing on both sides, I'm allowed. So if we bring in a positive on both sides, what can we then do? Make a 0 and take it out. Now the other thing we could do if I reset this, and this is what I was thinking, and why when Araya said that at first I got taken aback. If I bring in this, give eyes up here please. If I bring that in, how much is this worth? 0. I can put 0 on this side and now take these away. And it's the same thing. X is greater than 3. So please on your paper write x is greater than 3. Like that. X is greater than 3. Now, how we graph that is super duper ooper pooper easy. I couldn't think of any other oopers. Don't draw this. Don't draw that, because I like you. Draw this. And you already have written down that. Here's the trick that, I don't know, certain math teachers don't want to tell you for some silly reason. Once we get to this point, we only care about one number. And that number is 3. Now, x is the thing we don't know. We are going to color where x is allowed to exist, but the number we care about is 3. So go ahead and put a 3 right in the middle of your number line. If you want, you don't have to. You could show that, like 0's out here and some higher values are up here. You don't have to, though. What we now do is at our number we care about, we circle it on the number line. Do not shade that unless, don't do this. Please do not do this, just watch for a second. If this was x was greater than or equal to, then we would shade this. But because we don't have the or equal to, we do not shade this circle. Does that make sense? X cannot be 3, but x can be anything bigger than 3. So since x is anything bigger than 3, we start our shading right against that circle, and we shade and put an arrow at the end of it to say, yeah, it's going to keep going. It's anything bigger than 3. So x could be 4, or 5, or 6, or 7, or 1,000, or 800, 572 million. Doesn't matter. It's anything bigger than 3. Or it could be 3.0000000000001. If it's bigger than 3, this is true. Right?
Okay, so I'm not confused, but still how do you know that x is bigger than 3?
Because we made that true. Thank you for asking. But we said we don't like the question mark, so I'm going to put in greater than and then make it happen. Now, if I put in less than, same process, but this, less than, if this was less than, right, pointed the other way, we'd shade this way. But that's if we made that happen. Now, to answer your question really, you won't normally have to make it happen. They'll give it to you. So now, and I think this might be on your paper. I make these, but then I forget. Yeah, 27's on your paper. So 2x plus 5, you could write this down again, less than 3. Or you could build it on your expression mat. If you want to build this on your expression mat, grab 2 x's, grab a little piece of paper and say less than if you want. Grab 5 1's, grab 3 1's.
Wait, which side is this?
Left side versus right side, right? So if we do 2x plus 5 is less than 3, it'll look like 2x plus 5 is less than 3. Oh, my bad.
Can we use the long pause?
You can, but don't. And I'll show you why in a second. Maeve, what can I do on both sides? Take away 3. So
That's all you can do.
that's very insulting to say that's all I can do. I can do a lot. Now, Meredith, because you wanted to volunteer, if I bring this in on this side, does it change anything? Because that's just 0. So if I bring this in on that side, does it change anything? No, because that's just still 0. Now, can I do something else?
Yeah, you can take away the 2.
Yeah. So what we get is 2x is less than 2, or split this group in half. Each x can match up with one of the negatives, so x is less than -1. And we can write all that out. Please do this with me. Write this out with me. I'm almost out of time. What we did, it's way quicker when we do the algebra. Check, what we did was get rid of the 5. Actually, I'm going to write that in white. Seems like a better idea.
Well, we only have one.
Get rid of the 5. Now, remember when we said we can't do this, but then we make it happen? I can't take 5 away from 3. Can't. If I'm trying to buy something for $5 and I only have 3, I can't. But the magic of a credit card, I swipe my card and I go in debt. How much? How many dollars? 2. I go in debt by $2. Right? 2x is less than -2. And then to solve what x is, we divide by 2. Divide by 2. We split this whole thing up. X is less than -1. All right, guys, while you're making sure you have that copied down, please stop. While you're making sure you have that copied down, I will tell you, I'm behind of where I normally am in the year, but I am moving at the pace that I think is better for you. If you're at all behind on Chapter 6, you have to take this weekend as your opportunity to catch up and understand what's going on and ask questions if you don't. You gotta. Like, please, for you. You're not doing me a favor, but do yourself a favor. And if this stuff isn't making sense right now, you gotta get on top of it now before we keep going deeper into the chapter. Right? We got a lot more in Chapter 6, but like, we're only 3 days into it. If you let yourself not understand what's going on, yeah, it'll only keep getting harder. We're gonna do another one. So on your graph paper, you don't need your tiles, so you can put them back in the bag if you want. We are going to write on your graph paper 6 is greater than 2x plus 2. Oh, I left my cards over here. Oh, you want to tell me what I can do?
Take away 2 from both sides.
Say it louder, Aria.
Take away 2 from both sides.
Take away 2 from both sides. Because I want to work towards getting my x by itself. Here, we're fortunate. We can actually do that. 4 is greater than 2x. Mirabelle, what could I do now? I don't want 2 x's. I only want 1. I can't take an x away, though. That's the problem. Like, literally cannot because there's no x. We can divide. We can split this. So we divide by 2. Divide by 2. And guys, physically, on the algebra mat, it would just split the group like we just showed. Here, now, we're going to graph this because this is tough. Molly, come back to math class. You are in your brain staring somewhere over there. If 2 is greater than x, Toby, come back to math class. This, I only need 1 more minute, guys. You're making this take longer. This, I can pick up, flip the whole thing over, and say, well, that also means x is less than 2. Right? I flipped everything around. 2 is bigger than x. X is smaller than 2. So when we go to graph it, what's the one number we put on here? 2. Does my circle get filled in? No, because there's no or equal. And do I shade left or right? Left for less, right? If x is less, I shade left. Here's the other secret. If x is your first value, this points the way you shade. If x is the thing you read first, this points the way you shade. Literally. Like this, the inequality symbol. The inequality symbol is pointing the way you shade. Because you're going to point towards x, like what you're allowed to be. X is less than 2. It's allowed to be any of these values. Questions? Good, because you're out of here. Have a great day. Goodbye.
Mr. Hudson,
Sir.
could you tell me about the video challenge thing?
Oh, so I will even leave the recording on while I show you this. It is, if you just Google Math Counts Video Challenge, except my computer is struggling because I have so much stuff happening. As soon as you start typing it, it's going to pop up.
Okay.
This will tell you all the information you need to know.
Awesome.
This is not the true submission date. That's to win extra prize drawing opportunities.
Okay.
So the actual submission date is March 7th, I want to say. And the only thing I have to do is be the coach that is like signing your paperwork. March 6th. So that is the day after our discovery days. So if you decided to do this, you could finish it on discovery days, and I just would have to submit it on that Friday. Let me know if you guys decide to do it, man.
Okay.